Does this look familiar to you? That's right. At first glance, it's just a regular bearing, the kind you see all the time in machines, vehicles, or everyday mechanical setups. Nothing special, at least not on the surface. But in this video, I'm going to do something a little unusual. I'm going to turn this bearing into a homemade antenna. Sounds hard to believe, I know. A bearing as an antenna? That's the kind of idea that usually comes up as a joke in the workshop. But trust me, it actually works, and it's not just a gimmick. If you're curious how this is even possible, stick around and I'll show you exactly how I do it step by step. Next, I have a male electrical plug here, and this is actually an important part of the homemade antenna. It might not look related at all at first, but you'll see in a moment why I chose to use it.to make the assembly process easier and more organized. I'll take this plug apart piece by piece. There's nothing complicated here. Just go slowly and carefully so none of the internal parts get damaged. After taking the plug apart completely, I'll cut this cable into two sections, with lengths that have been calculated in advance. These two cable pieces will be used to connect the signal receiving part, the bearing, to the male electrical plug. If you'd like to follow along, you can refer to the measurements shown on the video screen. To give the two cable sections a stronger structure, so the signal receiving part stays firmly in place and doesn't wobble, I'll bend both cables into a spring shape. This design allows them to handle downward pressure more effectively, keeping the overall structure stable during use. There's nothing more suitable than a power outlet to use as the antenna base. It not only connects securely to the plug assembly, but also carries the signal through the coaxial cable in a clean and efficient way. Or if you're from the repair trade, then this coaxial cable in my hand probably looks very familiar. But if you're new to this, let me give you a quick introduction. A coaxial cable is designed specifically for signal transmission. Inside, it has a central copper core that carries the signal, surrounded by an insulating layer, a braided shield to reduce interference, and an outer protective jacket. Thanks to this structure, coaxial cable offers excellent noise protection and stable signal quality, which is why it's commonly used for antennas, TV systems, radios, and other wireless equipment. And in this project, it will carry the signal from our homemade antenna to where it needs to go. As for this remaining end of the cable, the way I connect it will be slightly different from the previous one. The goal here is for this end to connect directly to the TV. For this remaining end of the cable, I'll add a straight F connector and a 90-degree F connector. So when it's time to connect everything to the TV, the setup will be easier and more convenient, especially in tight spaces. Alright, everything is finished now. So the big question is, how will it perform in the real test? Honestly, I'm curious myself. No more talking, let's get straight into the test. Before connecting this antenna device to the TV, I want to check it first and show you clearly so everything stays transparent. At the moment, the TV isn't connected to any antenna or signal source at all, and you can clearly see on the screen that it's in a complete no-signal state. I'm doing this step first so that later, once we connect the homemade device, we can easily compare the results and see the difference. This is really impressive. Just a few seconds after connecting it, the TV is already showing a broadcast channel. That's honestly a bit surprising, but to know whether the signal is truly stable, we'll wait a little longer and keep an eye on it. After waiting for a while, nothing unusual has happened at all, and the signal remains stable. So I decided to disconnect it and plug it back in again just to see how it behaves after reconnecting. It's true that after reconnecting there was a bit of interference at first, but that's no longer an issue because after just a few seconds, the signal stabilized and the TV program continued to display normally. This clearly shows that the homemade antenna actually works in real-world use. Of course, it can't replace professional systems, but considering it's made from very common materials, the result is more than acceptable. Thanks for watching all the way to the end of this video.